CIST 2611, Chapter 12, we'll look at VPN implementation. So, in this chapter, we're going to cover the basics of a virtual private network, uh, including what they are, how they work, why they're important. As we go through this chapter, we'll be able to, at the end of it, describe the fundamental functions of a VPN, also identify common VPN technologies, and also understand the elements of VPN implementation and management. So, breaking down the key concepts of what we will be covering, the planning and selecting of appropriate VPN solutions for an organization. So, we're going to discuss the importance of careful planning when it comes to setting up a VPN for an organization. This includes factors like security requirements, scalability, and compatibility with existing systems. We'll also look at remote access alternatives for VPN because not every organization may need that VPN for the remote access. So we're going to look at other options that are available and discuss when the VPN would be the best choice. Also, there are various VPN technologies out that we're going to look at the strengths and weaknesses of some of these. So we'll look at some of the most common solutions available and discuss their pros and cons. Finally, we're going to walk through the process of deploying a VPN and ensuring it's working as intended. This includes testing for security vulnerabilities and ensuring that remote users can access the network seamlessly. All right, first we're going to look at operating system-based VPNs and VPN appliances. So the operating system-based VPNs, these VPNs are installed directly on computers running commercial operating system, such as Windows, Linux, and Unix. They're going to provide a software-based solution for establishing secure connections over the internet. Now, on the other hand, VPN applications, these are hardware-based devices, and they're specifically designed to handle VPN connections. So how they work is with the hardware-based VPN, they typically come with some built-in security features, and they're optimized for handling encryption and decryption tasks. And the remote users, they use the public IP addresses assigned to the appliances to connect. So this IP address, it serves as an entry point to the organization's network, and it allows the users to securely access resources from anywhere that's got an internet connection. Now, we configure a VPN appliance. A couple things we talk about. One is it does have a simple installation. So most of these VPN appliances are designed for an easy and quick setup. You can typically plug the appliance into your network between your ISP connection and your internal network. You also have web-based configuration. So once the appliance is connected, you can log it onto a web page that's provided by the manufacturer of the appliance. And there you complete the configuration process. So this usually involves filling out the form with necessary details and preferences. You want to change that default settings. So it's very important to change those default settings of the VPN. And this is done to enhance the security. So this includes setting up a strong encryption protocol, configuring your firewall rules, and also it's enabling authentication mechanisms. So also, each VPN user should have their individual access account to ensure the accountability and security. Now, these accounts are created using the configuration process. They typically include the username, passwords, and the access privileges. Now, on the client side configuration, we'll talk about the software configuration. So the users connecting to the VPN will need to configure software on their computers. Now, for smaller installations, Microsoft or Mac VPN client software is commonly used. Now, for Linux and Unix systems, there may be built-in client VPN software available, and this simplifies the configuration process for the users on those platforms. All right, so now we're going to look at some of the features and functionalities of remote desktop protocols. and the remote desktop connection. So the remote desktop protocol, this was developed by Microsoft. It's a proprietary protocol created by Microsoft. It allows users to access and interact with a GUI, a graphical user interface, of another computer over a network connection. So with the RDPs, so the users on this can remotely control another computer and view its desktop, and it's like they were actually physically present in front of it. So this enables a seamless collaboration and remote support. It is based on the ITU-T T.128. This is an application sharing protocol, and it allows real-time sharing of applications and desk works, once again, over the network. Now, the remote desktop connection, this is a built-in application that uses the RDP. This was an application provided by Microsoft. It uses, once again, that RDP protocol. It allows the users to establish remote desktop connections to other computers running the Windows operating system. Now, once connected, users can log on to the remote computer and perform virtually any action as if they were actually physically sitting at that remote location. So this includes accessing files, running applications, and performing administrative tasks. Now, while this RDC is primarily used on Windows systems, clients running other operating systems such as Mac, Linux, Unix, they can also connect to remote desktops using third-party applications that support the terminal service protocol. Now, some remote control tools that we're going to look at that can facilitate efficient support and collaboration. One will be remote assistance. Now, this is a feature that's integrated into Windows operating system. It enables help desk professionals or your IT administrators to remotely access and control a user system for troubleshooting purposes. Now, with remote assistant, the user remains actively engaged as they can observe the actions being performed on the system in real time. This allows for a clearer communication and faster issue resolution. There are some third-party tools also, TeamViewer, LogMeIn, Remote PC. These tools offer a range of features and functionalities beyond what's provided by the built-in Windows utilities. And these may have additional features like file transfer, session recording, or multi-platform support. Then we're going to look at how remote access. This enables connectivities for users that are either on the road or on the go. Sometimes you may have sales professionals that are on the road that need to access company resources. That would be an example of a remote user. Field technicians would be a remote user. They may need access, have remote access to for troubleshooting issues, access manuals, or update records. External consultants working at a customer's locations. They may need access to internal company resources. Also, anyone authorized who needs to have access to internal company resources while they are away. There's maybe employees working from home or traveling for business. So those will be what we would consider remote users. Now, the VPN, once again, we've talked about this, uses tunneling protocols to establish secure communications. And that allows those remote users to access those internal company resources. Now, the tunneling protocols include different types of encryption to protect data. So there are a lot of different tunneling protocols, PPTP, LTTP/IPsec, and OpenVPN. These are used to establish encrypted tunnels between the user's device and the company's network. And those tunnel protocols, they employ different types of encryptions. It may be an advanced encryption standard, the AES. Um, Maybe one of them they use to protect that data is transmitted over the VPN. So some of the technology that is used to facilitate secure remote access we'll look at now. First, we'll start off with point-to-point tunneling protocol. This is one of the earliest tunneling protocols used for creating VPN connections. It's widely supported by different operating systems and devices. Now, while it does offer the ease of setup and compatibility, its security is considered weaker compared to the other protocols. The Layer 2 tunneling protocol. It's a tunneling protocol that combines features of the PPTP and the Layer 2 forwarding protocol. Now, it does provide better security using encryption and authentication mechanisms, and it's something that's commonly used in conjunction with IPsec for enhanced security. The secure socket layers / transport layer security, these base tunneling protocols, this is something like OpenVPN. It provides secure connections over the internet. They use the SSL TLS encryption to secure the data that's transmitted between the client and the server. Now, these protocols are highly versatile and can operate on various ports, so it makes them suitable for bypassing firewalls. Last, we'll talk about the Internet Key Exchange version 2. Now, this is a protocol that establishes and manages security associations for IPsec. It does offer high reliability, and it does support seamless roaming between the networks. So this is something that makes it ideal for using it with the mobile devices. IKE v2 also provides strong security features and efficient reconnection capabilities. So we'll talk a little bit more about Microsoft's remote desktop services. Once again, this is an integrated Microsoft service. It's designed to facilitate remote access and virtual desktop deployment. It offers multiple uses and configurations to meet various organization needs. Now, it does work in two main modes. The remote desktop session host. So, what's in this mode, the server typically provides pools of data of desktop sessions and applications for everyday user workloads. So the users can access shared desktop sessions or specific applications that are hosted on the server. It provides them a familiar work environment. Now, the remote desktop virtualization host, in this mode, the server typically provides personal desktop sessions within virtual machines. So each user is assigned their virtual desktop. It's going to operate independently, similar to their primary workstation. Now, some key features of the RDS, you can have multiple virtual desktops. So it allows administrators to provide multiple virtual desktops, so that each can be tailored to individual user requirements. Those users can access their virtual desktops remotely, and just like their primary workstation, um, so regardless of where their physical location is, they can access those remotely. You also have centralized management. Um, so the RDS enables centralized management of the virtual desktops and applications, and this simplifies administrative tasks and ensures consistency across the environment. RDS also offers flexibility and scalability, and that can be used to accommodate the varying workloads of user demands. It makes it suitable for organizations that are of all sizes. So with remote desktop services, I will look at some of the additional features here. First, we'll look at the RD remote app. This is a Microsoft solution, so it's a component of that Microsoft RDS, and allows applications to be hosted on the RDS server and delivered to the end user's devices. Now, when you're using this, the end users perceive the RDS remote app applications as if they were running locally on their system. So, and this is also regardless of the operating system they're using. The RD Web Access is an RDS server role that enables users to launch desktops and RD remote app applications directly from their web browser. Now, it does have a dependency on the Internet Information Services. That is a web server role in the Windows Server operating system. Now, the RDS and hosted services, uh, these with this, an internet service provider, software vendor, leases applications to the organizations rather than selling them outright. So these leased applications run on the service provider's servers and allows the users access and be able to interact with them over the internet. All right, Microsoft Direct Access. This is a solution that's provided by Microsoft that offers alternatives to traditional internet VPNs for secure remote access to internal resources. Now, some key features of this include seamless connectivity. So, direct access allows remote clients to connect to internal servers without the need to manually initiate a VPN connection. Also, the client computers can connect to the direct access server, and that's going to act as a gateway to internal resources. So, this eliminates the need for the users to navigate complex VPN configurations. Also, direct access can be configured to allow access only to resources specifically configured for direct access. So, this just enhances your security by restricting access to sensitive internal resources. So, we see the examples where you configure a Microsoft Exchange server with direct access. So, when a direct access enabled window client connects to the internet, it automatically establishes a connection to the direct access server. And when the user launches Microsoft Outlook, direct access seamlessly establishes a connection to the internal Microsoft Exchange server. And it does this without requiring any additional user information. A DMZ is a physical or logical subnetwork that's going to sit between an organization's internal network and a larger, untrusted network, typically the internet. It hosts and exposes the organization's external facing servers, such as your web server, email servers, and DNS servers, to external users. But it adds additional layer of security by segregating the external facing services from the internal network. And this reduces the risk of unauthorized access to your sensitive internal resources. Now, intranet is an internal network that is privately accessible only to authorized users within an organization. Intranet VPN establishes secure connections between two or more internal networks. And it enables secure communications and data exchange over the internet or other shared infrastructure. It also provides a secure means of connecting geographically distributed offices, branches, or departments that are within the same organization. And this is also ensures the confidentiality and integrity of the internal communications. Now, the extranet VPN, this extends the concept of that intranet VPN to include external parties such as customers, suppliers, partners, or communities of interest. So it allows authorized external users to securely access specific resources or services that are on the organization's intranet over a shared infrastructure. This is something that's typically the internet. The extranet VPNs can also be configured to use various network technologies, including lease lines, dedicated connections, or encrypted tunnels over the internet, depending on the security and performance requirements. An internet cafe is a public location that sells internet access, often by the minute. These cafes provide a convenient option for individuals who do not have internet access at home or need a temporary workplace. Now, when you're connecting to the internet at an internet cafe, users may be vulnerable to security risks, such as malicious attacks or data interception due to that shared network. So, to mitigate these risks, some organizations offer internet cafe VPN connections as a secure option for their employees and users. Now, when an internet cafe VPN connection is used, users connect to a VPN server that's hosted by their organization, regardless of where their physical location is at. This connection encrypts the user's internet traffic and is protecting it from potential threats and ensuring the privacy while browsing the web. So now we're going to look at some of the security features and capabilities of online remote VPN options. We'll start with the Wake on LAN. Is a feature that enables users to remotely power on or wake up a computer over a network connection. Now, some VPN solutions offer the Wake on LAN support, allowing users to wake up their devices remotely and establish VPN connections for secure access. Now, sharing files securely is essential for remote collaborations and productivity. So many VPN services provide encrypted file sharing capabilities. And this allows users to transfer files securely over that VPN connection without exposing the sensitive data to unauthorized access. Remote printing allows users to print documents from the remote devices to local printers that are connected to the network. VPN solutions with remote printing support that enables seamless printing functionality and ensures users can print documents securely from that remote location. Now, support for Mac and mobile devices is important for ensuring compatibility and accessibility across different platforms. So many VPN providers offer dedicated client applications, whether it's for the Mac, iOS, Android, or other mobile operating systems. All right, the Tor application is designed to provide anonymity and security for for users browsing the internet. That utilizes a technique called onion routing to optimize the internet traffic and protect the user's privacy. The Tor application, so it was designed as architecture to mitigate vulnerability of networks to eavesdropping and traffic analysis. So it uses multiple proxy servers or relays to provide anonymous connections. And each proxy server knows only the details about the previous proxy server or the next proxy server. So these provide that anonymous browsing for users by requesting access to resources or making it appear as the proxy server is requesting the access, not the original user. Once again, like I said, the goal of the Tor is to allow users to browse the internet anonymously. Now, some considerations and features that are involved in implementing a VPN. First, we'll look at OpenVPN. OpenVPN is an open source VPN solution. It's compatible with a variety of operating systems, including Windows, Linux, and others. It also facilitates the creation of site to site VPN tunnels that enable secure communications between different network locations. Now, some key features for OpenVPN, it supports multiple encryption methods, including pre-shared secret key encryption via static key, and the SSL/TLS security with the client server certificates. All right, so OpenVPN also supports non-encrypted tunnels using TCP or User Datagram Protocol through proxies or NAT. So on that, the network at both ends of the VPN tunnel must use different IP address ranges to avoid conflicts. Internet protocol security, on which the VPNs are based, does not tolerate the network address translation of data packets. As I said, networks on both ends of the VPN tunnel must use different IP addresses. And permanent site-to-site VPNs, they require firewalls at both ends that use static IP addresses. This ensures stable and reliable connectivity between those two network locations. So now we're going to talk about the configuration process for OpenVPN. This includes required fields and key considerations. OpenVPN typically requires a configuration file and key files for setup. These files define the parameters of the VPN connection and provide security through encryption and authentication. Now, for a simple VPN setup with a single server and a client, a static key setup, which is your secret key, can be used instead of creating a public key infrastructure with key pairs and certificates. So this simple configuration process, this simplifies that configuration process while still providing the encryption for the VPN connection. Configuration files for the OpenVPN includes comments indicating where or which items need to be modified. Directives and attributes preceded by a semicolon are ignored, while removing the semicolon allows directives or attributes to be read and acted upon. It's also important to ensure that parameters in the client configuration file match those in the server configuration file. So parameters such as the device, protocol, port must be consistent for proper communication between the client and the server. You also want to ensure that the UDP port 1194 is open on the server to allow incoming VPN connections. So this port is commonly used by OpenVPN for communicating, and open it ensures the clients can establish that connection with the server. So testing and troubleshooting steps to ensure the VPN connectivity using OpenVPN. To verify the VPN is running correctly, you want to issue the ping command from both the server and the client. So, for example, you ping 10.8.0.2 from the server command prompt to reach the client, where you'll ping 10.8.0.1 from the client to reach the server. So, if that ping fails, you want to check the firewall settings to ensure that they are configured correctly. You want to make sure you open up UDP port 1194 on the firewall to allow that VPN traffic to pass through it. Alternatively, you can also set up a port forward rule to forward that UDP port 1194 on the firewall to the machine running the OpenVPN server. You also want to ensure that the TUN-tab interface used by OpenVPN is not firewalled. Now, firewalls blocking that interface can prevent the VPN traffic from flowing properly. And some other things you might need to create a name for each remote VPN connection in the zone files. That defines the network zones and their corresponding interfaces. So you assign names to remote VPNs, and it helps identify and manage connections effectively. You also might need to describe what IPsec interfaces to use for each VPN connection based on the names defined in the zone files. So this ensures that the VPN traffic is correctly routed through the appropriate IPsec interface. You may need to describe how networks named in that zone file interact with each other in the policy file. So you define access control rules and policies that regulate the traffic flow between the different network zones, including your VPN connections. Also, in the tunnel files, you want to define the public IP addresses of remote sites participating in the VPN connections. So this information is important for establishing secure communication channels between the VPN endpoints. Now, OpenVPN Private Tunnel is a straightforward solution designed to create a personal VPN tunnel to ensure encrypted connections and anonymous IP addresses. So it offers a simplicity in its setup and usage. This is something that makes it an ideal choice for individuals or the small office/home office settings. Some key features in this: it has the private tunnel encryption connections, so it safeguards your data that's transmitted over the internet from unauthorized access or interception. By masking the IP addresses, private tunnel enhances privacy online, ensuring users remain anonymous while browsing the web. The setup process of private tunnel is user-friendly, allows for quick and hassle-free configuration without the need for a lot of technical expertise. Once again, it's well suited for the small office/home office environments. Provides some secure connectivity for remote workers and personal use. So, some essential best practices for VPN implementation. These are to ensure the security and reliability. You want to use strong authentication. So, you want to implement those strong authentication mechanisms, such as a username password authentication or multi factor authentication to verify the identity of the VPN user. You also want to utilize robust encryption protocols, such as the Advanced Encryption Standard, to encrypt the VPN traffic and protect the data transmitted over the network. So those strong encryptions, those safeguard that sensitive information from interception and ensures the confidentiality and integrity of the data during transit. You also want to protect the VPN server behind a firewall. So you deploy that firewall to protect that VPN server from the unauthorized access or malicious attacks. Configure the firewall to restrict incoming and outgoing traffic to the VPN server, only allowing authorized VPN connections. You also want to make sure that you regularly update your firewall rules and configurations to mitigate any security risk and vulnerabilities. So when you implement a virtual private network, this involves several key steps to ensure its effectiveness and security within the organization. Planning and selecting an appropriate VPN solution. So you want to assess the organization's requirements, including the number of users, remote access needs, and security considerations. Then you evaluate various VPN solutions based on the factors such as encryption protocols, authentication mechanisms, the scalability, and compatibility with your existing infrastructure. And then you choose that VPN solution that aligns with the organization's budget, security requirements, and usability for the end users. You also want to explore remote access alternatives to VPNs. You will consider alternative remote access solutions such as the remote desktop services, remote assistance, remote control tools, and these are based on specific use cases and requirements. So you evaluate the pros and cons of each alternative in terms of security, ease of use, and compatibility with the organization's needs. Finally, select a suitable VPN solution. So you determine the type of the VPN solution needed based on your organization's requirements. This may be because you need site-to-site VPNs for inter-office connectivity, or it may be that you need remote access VPNs for individual users. So you choose from a range of VPN technologies. This may be the Open VPN, IPsec, SSL/TLS based VPNs, or it may be a proprietary VPN solution. Once again, you base these factors on the security, scalability, and the ease of deployment. Finally, you deploy and test the VPN. So you implement the chosen VPN solution, following the best practices for configuration. That includes the strong authentication, encryption, and the firewall protection. You want to conduct thorough testing of your VPN infrastructure to ensure that it's functioning properly. You want to ensure that you have connectivity and security. Test the VPN connections from different client devices and network locations to verify the compatibility and performance. And then also regularly monitor and maintain your VPN infrastructures. This is to address any issues or security vulnerabilities that may arise. So when you follow these steps, you can effectively plan, deploy, and manage VPN solutions that provide secure and reliable remote access for users while also meeting the organization's operation and security requirements.